Have you ever looked at the starry sky wondering how many stars you were seeing? 10,000? 100,000? Well, prepare to feel dizzy. There are more stars in the observable universe than grains of sand on all the beaches on Earth. Yes, you heard that right. And today, we're going to explore 5 incredible facts about astronomy that will completely change the way you look at the night sky. Welcome to iAnecdote. If you already follow me on short formats, you know we love sharing fascinating facts that spark curiosity. Today, we're taking it to the next level with our first long-format video. And what better subject than astronomy to celebrate this? Over the next few minutes, I'm going to tell you 5 extraordinary stories. From the dizzying immensity of the universe to the shooting stars you observe every summer, passing through the secrets of Saturn, the origin of our cosmos, and the mysteries of Mars. So sit back comfortably and let yourself be transported into space. Let's go! Part 1. The dizzying immensity of the universe. Let's start with a reality that exceeds human imagination. There are more stars in the observable universe than grains of sand. On all the beaches on Earth, this number is so astronomical, no pun intended, that it becomes almost abstract. But let's try to make it more concrete. Every point of light you see in the night sky is actually a massive sun, often millions of times larger than ours. And around each of these suns orbit countless planets, moons, and comets. Many of these worlds remain totally unknown to us. Some burn under infernal temperatures that would evaporate lead in seconds. Others are lost in eternal nights, plunged into endless darkness. Thanks to the James Webb Space Telescope, the successor to the legendary Hubble, we've already discovered exoplanets located hundreds of light years away from us. To give you an idea, a light year is the distance light travels in 1 year at a speed of 300,000 kilometers per second. It's absolutely colossal. And over these unimaginable distances, light literally takes centuries to travel before reaching our eyes. What this means is that what we see in the sky is the past. When you look up at the stars, you're contemplating images that sometimes date back several thousand, even millions of years. Some of these stars you admire may have died long ago, but their light continues its journey to us, like a posthumous message crossing the cosmos. And here's what's both terrifying and wonderful. Despite this crushing immensity, everything obeys a few simple physical laws. Gravity, electromagnetism, cosmic expansion, the same forces that keep a cup on your table, hold together entire galaxies composed of hundreds of billions of stars. The universe is like a book with infinite pages, and we've only read a tiny portion of it. But each discovery, each new observation reminds us of a troubling truth. The universe is not empty. It's alive with light, movement, and stories. And everything we are, our body, our bones, the atoms that compose us, everything comes from this stardust scattered billions of years ago during cataclysmic stellar explosions. In other words, we are literally made of stardust, and that's simply magnificent. Now that you've grasped the dizzying scale of the universe, let's zoom in a bit and get closer to our own solar system. Because even in our cosmic neighborhood, there are breathtaking wonders, and one of the most spectacular is undoubtedly Part 2. Saturn, the photogenic queen of the solar system. Saturn, the most photogenic planet in our solar system. With its majestic, sparkling rings, it has fascinated us since Galileo first observed it in 1610. But what you may not know is just how incredibly thin these rings are. To scale, if you reduced Saturn to the size of a basketball, its rings would have the thickness of a simple hair, yet their diameter extends over more than 280,000 kilometers. It's this combination of immensity and thinness that makes Saturn so unique and elegant. These rings are composed of a mixture of pure ice and rocky dust. Their origin is still debated, but the most likely hypothesis is that they come from the remains of an ancient moon that was pulverized, either by a collision or by Saturn's tidal forces. Their composition varies enormously from one area to another. Some sections reflect light like a bright mirror, while others are dark and granular, loaded with denser materials. The Voyager probes in the 1980s, then Cassini between 2004 and 2017, traveled along the edges of these rings and revealed delicately carved, almost artistic structures to us. The Cassini mission in particular was a masterpiece of space exploration. Before its programmed end in 2017, the probe voluntarily dove into Saturn's atmosphere to avoid contaminating potentially habitable moons. But before that, it offered us its last breathtaking images. These images showed a world of colossal storms and winds reaching 1,800 kilometers per hour. To give you an idea, the most violent hurricanes on Earth barely reach 300 km/h. On Saturn, it's 6 times faster. And here's an even more surprising detail. Saturn is so light, it would float on water if we found an ocean vast enough to accommodate it. Its density is lower than that of water, making it the only planet in the solar system with this characteristic. Its atmosphere swirls in golden and bluish bands, painted by the titanic forces of winds and the complex chemistry of the gases that compose it, mainly hydrogen and helium, with traces of methane and ammonia. But beyond the planet itself, it's its moons that captivate scientists today. Titan, the largest, has a thick atmosphere and lakes of liquid methane on its surface. Enceladus, meanwhile, shoots geysers of salty water into space, suggesting an underground ocean that could harbor life. This gas giant, beyond its beauty, embodies everything the universe has that's both fragile and grandiose. Seeing Saturn through even a modest amateur telescope is to contemplate geometric perfection suspended in the void. Few images in the universe remind us so powerfully that nature, even billions of kilometers away, can be spectacular. After admiring Saturn's splendor, let's now go back to the very origins of everything that exists. Because if the universe is so vast and beautiful, where exactly does it come from? This is where a fascinating story comes in involving a Belgian priest, a skeptical physicist, and a theory that would revolutionize our understanding of the cosmos. Part 3, The Big Bang and the Visionary Priest Here, is a question you've probably already asked yourself. Where does the universe come from? How did it all begin? The most accepted answer today is the Big Bang. But what many don't know is that this theory wasn't invented by an atheist physicist, but by a Belgian priest passionate about astrophysics, Georges Lemaitre. In 1927, this Jesuit scientist proposed an absolutely revolutionary idea. The entire universe would come from a primeval atom, a sort of infinitely dense and hot point from which everything would have emerged. At his time, this idea seemed completely absurd. The dominant view was that the cosmos was eternal and immutable, a static backdrop that had always existed as such. Even Albert Einstein, the genius who had revolutionized physics with general relativity, doubted the validity of Lemaitre's model. Einstein had actually introduced a cosmological constant in his equations, precisely to prevent the universe from expanding or contracting. He wanted a stable universe, but he was wrong. It was American astronomer Edwin Hubble who, by observing distant galaxies, discovered that they were all moving away from each other. And the farther away a galaxy was, the faster it was moving away. It was as if the entire universe was drawn on a balloon being inflated. All points move apart simultaneously. The universe, instead of being stable, was in constant expansion. This discovery completely revolutionized our cosmology. The Big Bang wasn't an explosion in space as we often imagine it, but the expansion of space itself. Every parcel of energy, every particle, every photon of light began in unimaginable density and temperature, concentrated in an infinitesimal point. But how can we be sure? The most convincing proof came in 1964, with the discovery of the cosmic microwave background. This is microwave radiation that covers the entire sky today. This radiation is a fossil trace of the Big Bang itself, emitted a few 100,000 years after the beginning of the universe, when it became transparent for the first time. This background is invisible to the naked eye, but specialized telescopes can detect it. What's fascinating is that each tiny fluctuation in this radiation encodes the history of matter and galaxies. It's like an ancestral map that tells us how the first cosmic structures formed. What makes this story even more remarkable is that an initially metaphysical hypothesis, almost philosophical, proposed by a priest, was validated by the most rigorous experimental physics. Georges Lemaitre, both a man of faith and a scientist, saw in this beginning of the cosmos the elegance of a rational and comprehensible universe. A century later, His idea remains the cornerstone of modern astrophysics, and it reminds us that science and spirituality are not necessarily opposed, but can sometimes converge toward the same quest: understanding where we come from. From the Big Bang that created the universe 13.8 billion years ago, let's now leap to our solar system and take an interest in a planet that has fascinated humanity forever. A planet that could well become our second home in a not-so-distant future. Part 4. Mars, mirror of our origins and our future Mars. The red planet. It's both familiar and distant, close and mysterious. Its pink sky at sunrise and its vast dusty plains evoke an endless desert, frozen in time. But here's what makes Mars absolutely fascinating. Multiple clues show that once liquid water flowed there. How do we know? By observing its surface. Eroded valleys, fossil riverbeds, dried deltas. All of this testifies to an aquatic past. Martian missions like Curiosity and Perseverance, these explorer robots currently traversing the Martian soil, have confirmed the presence of clays and minerals that can only form in an aqueous environment. And this changes absolutely everything. Because where there was liquid water, life may have had a chance to appear. Not necessarily complex life with little green men, but at least primitive microbial forms. And if life emerged independently on Mars, it would mean that the emergence of life in the universe is much more common than we think. But today, Mars is a dead world. Its atmosphere is so thin, about 100 times less dense than Earth's, that any drop of water would evaporate or sublimate instantly. The atmospheric pressure is so low that water cannot exist in liquid form on the surface. It's as if you were in a gigantic cosmic vacuum. Why did Mars lose its atmosphere? The main reason is the absence of a global magnetic field. Unlike Earth, which has a protective magnetic shield generated by its molten metallic core, Mars no longer has this shield. Solar winds, these flows of charged particles emitted by the sun, were therefore able to gradually strip away the Martian atmosphere over billions of years. It's a slow but relentless process that transformed Mars from a potentially habitable world into a frozen desert. Yet, all is not lost. Under its surface, water ice still remains, particularly at the poles and in certain underground regions. Martian dust storms, meanwhile, are spectacular. They can engulf an entire hemisphere for weeks, creating red dust vortexes visible from Earth. Humans have dreamed of walking on Mars for decades. The first crewed missions, currently planned for the 2030s, could transform this fiction into reality. Imagine for a moment, walking on soil 4 billion years old, watching a blue sunset. Yes, blue because of the way Martian dust scatters light, and realizing you're on another planet. It would be an experience that would completely redefine the notion of home. Mars, ultimately, is the mirror of our origins and perhaps our future. It shows us what happens when a planet loses its magnetic protection. It reminds us of the fragility of our own world. And it perhaps offers us a second chance, a new home for humanity, if we learn to terraform it and establish sustainable colonies there. Transition. After exploring Mars, our possible future home, let's now return to something more immediate, more poetic too. A phenomenon you've certainly already observed on a summer night, lying in the grass looking up at the sky. Part 5. Shooting stars. Cosmic messengers. Let's look up at the night sky one last time. If you've ever spent a night observing the stars, you've definitely seen a shooting star cross the sky in a fraction of a second. And maybe, like many, you made a wish. But here's the truth. Shooting stars have absolutely nothing to do with a star. They're actually grains of dust, sometimes no bigger than a grain of sand, that ignite when entering Earth's atmosphere, at speeds exceeding 70,000 kilometers per hour. At this phenomenal speed, friction with the air generates such heat that these particles vaporize instantly, creating that luminous trail we find so beautiful. Yet, despite their modest nature, shooting stars have always fascinated. Ancient civilizations saw them as divine messages, signs of destiny or souls ascending to heaven. Each year, several meteor showers return on fixed dates, like the Perseids in August or the Geminids in December. These shooting star showers are actually caused by comets. When a comet passes near the sun, it leaves behind a trail of debris, pebbles, dust, ice. And when Earth crosses these zones in its annual orbit around the Sun, these debris enter our atmosphere and create this celestial fireworks display. Some meteorites, more massive, survive the passage through the atmosphere and reach the ground. We then call them meteorites. Scientists collect and study them passionately because they contain precious information about the birth of the solar system 4.6 billion years ago. And here's something absolutely fascinating. Some of these meteorites contain amino acids, those fundamental chemical building blocks that make up proteins and therefore life. The idea that these space fragments, fallen on the primitive Earth, may have contributed to seeding our planet and starting the process of life makes their fall even more poetic and meaningful. Watching a shooting star is therefore literally observing cosmic dust becoming light again. It's a moment of pure beauty and a trace of our planet's stellar past. In the darkness of a summer night, this universal spectacle connects the sky and humanity in a single gesture. A fragment of space billions of years old meets our atmosphere and disappears in a flash, but not without leaving us a memory. Conclusion, there we are. We've reached the end of this journey through the universe. We've explored the dizzying immensity of the cosmos, admired Saturn's majestic rings, discovered the origins of the universe thanks to a visionary priest, dreamed of Martian colonies, and contemplated the fleeting beauty of shooting stars. Each of these facts reminds us of a fundamental truth. We are both infinitely small in the cosmic immensity and infinitely precious. We're made of stardust. We live on a fragile planet suspended in the void. And we have the incredible chance to be able to observe, understand, and marvel at this spectacle. Astronomy isn't just a science, it's a door open to wonder, to humility, and to our place in the universe. So next time you look up at the starry sky, remember everything we've just discovered together. And if you enjoyed this long format, if these stories made you travel, then subscribe to Yanecdote to support us and follow more facts like this one. We have plenty of other fascinating subjects to explore together, and your support helps us continue sharing knowledge and curiosity. Thank you for watching until the end, and see you very soon for new scientific adventures.